Hello, Stephen Mendes from the Stephen Mendes channel. I promised you an in-depth look at programming the DX series of synthesizers, and one of the good things about working with the DX-27 as far as learning how to program it is concerned is that we only have 4 operators and 8 algorithms, whereas in the DX7 they had 32 algorithms with 6 operators. So really and truly it's a simpler task, and as we shall see, even with 4 operators you're getting a tremendous subtlety of tone, and we can in fact disable several operators without making only subtle changes to the tone. The other beauty of it is that it's very, very easy to program. Contrary to what you may have been told, once you get the hang of it, it's extremely easy to program. As you can see, the first 4 algorithms use stacked operators. In fact, stacked modulators, because the very bottom operator is going to be the carrier, and all the ones above it are going to modulate the wave shape. So these first 4 algorithms would be usable for complex wave shapes and for sounds that have inharmonic noise content, percussive sounds, and various nature songs and so forth. Having said that, these 4 are often used with piano, brass, and other things as well. So that means that your choice of algorithm is more complicated than simply thinking in terms of noise. But one thing is certain: the modulators at the top, in other words the ones farther away from the carrier, contribute far less to the sound. So from that point of view, this one here is a particularly popular choice, because this one here has the feedback operator and one without feedback, capable of modulating the carrier at the bottom. So out of these 4, it would be true to say that number 3 here is the most popular. Now in terms of the last 4, as you can see, they all have multiple carriers at the bottom. Starting with 8 over here, we have all the carriers in parallel. So this is suitable for mixing parallel combinations of sine waves, getting your Hammond organ tones correct, because that's where you have lots of sine waves mixed together. And one of the operators here has the feedback, which allows for a slightly different wave shape, more of a pulse or square wave type of thing. But essentially you're mixing all of your waves together, and most of them are going to be sine waves. Now here on operator 7, you're capable of having 1 modulator, which makes a slightly more complex wave possible here, wave shape possible, at the expense of having the 4. And then when you come down to 6 allows us to have a common operator with or without feedback modulating all 3, which is not a maximally popular one. This one here, 5, is the maximally popular of all, because this gives the best of both worlds. This allows modulation of the sine waves and allows you to have 2 separate components. So you can set up one with a completely different tone or sound. One can be a percussive sound and the other can be a static sound. So you can have a dynamic and a static, or any combination of 2 separate sounds. And in fact many of the patches that you use actually contain two components to the sound. One as the sound changes over time, so you can create one component with one stack and the other component with the other one. So that's about it for the modulators and algorithms and carriers, operators. We have 4 operators here, just so that you get your terminology right. In this algorithm we have 4 operators, 3 of them are modulators and 1 is the carrier, the bottom one. Okay, so that's it. Now you notice that there's no such thing as a filter in this kind of additive synthesis. However, we can produce filter-like effects, because all a filter does is change the harmonic content of the wave over time, usually driven by an envelope generator or an LFO. So if we actually use the envelope generator contained in the operator that's serving as a modulator to good advantage, then we can create filter-like effects. So that allows us to program virtually everything. Now the envelope generator here is a little ticklish, and people familiar with the standard ADSR may be a little disturbed because they don't see a sustain level. What happens to the sustain level? Well, as it turns out, if you set the delay time of D2, if you set the D2 delay time to 0, then this essentially leaves for a sustain here, and you can use the D1 level to adjust your sustain level. So in other words, you've effectively set D2R to 0, turning the thing into a normal A, D, S for D1L, and R for release. So by setting the D2R to 0 at any point in time, we can turn this into a standard ADSR envelope generator. Okay? So generally speaking, the change in numbers from 0 to 99 or whatever it happens to be, because it's 0 to 15 in the case of some of them, is not linear, and there's a range that has more of an effect than the rest of it. So we're going to demonstrate that for you now so that you can see for yourself what I mean. First of all, we have to initialize a voice. We just press the function button and we come over here and we select init voice, and then it comes here with it display says init voice with a question mark, and we press the yes button, and then we've got are you sure, so we press the yes button again and it's completely initialized. Now although all the operators are turned on and algorithm 1 has been selected, in fact only the first operator is actually active, and that is just going to play a sine wave without any kind of envelope. In order to demonstrate the audio effects of the feedback parameter of operators, we're going to change our algorithm to algorithm 8, which is easy to do. We just press the edit button. Actually, we're in the edit mode already, so we don't need to do that. We just press the algorithm button here in purple, and we come then and use the data entry slider. We can make it whatever we want. So we set the algorithm to 8. And then if we set the algorithm to 8, we're going to have to change the output, because the algorithm 8, the one with the As you can see there, the one with the feedback link is operator 4. So we come here now and we are going to turn on the output level on operator 4 instead of operator 1. Now the operator output level is here, so you just press that, and as you can see, it's got operator output 1 set for 90. So we're going to just use the data entry slider to carry that down to 0, and then we switch to operator 4 using the operator select button here. Press it. Each press changes the operator. Operator 4 is shown. And then we bring the data entry slider up and make that output 90. Okay? So we have now a sine wave playing on operator 4. Now it sounds a little lower than it did with operator 1, because when we've got the operators set up as carriers along the bottom, they all are mixed together so that we get similar volume for all the patches. Even with the output set at 99, the operator is not going to sound as loud here as it would if we had algorithm 1. But that's not a big disadvantage. You can just turn up the volume a little louder on your amplifier, and we're going to go and do that now. Okay, the next thing we do now is we press the feedback. Notice we're using the purple on the top of the buttons. We press the feedback button and we come back here and we see that our feedback level is 0. So what we're going to do now is we're just going to play a couple notes, and we're going to gradually bring the feedback level up. 1 doesn't make much of a difference. 2 not yet. 3, 4 begins to tell us something. Notice it's getting a bit more reedy than your normal sine wave. 5 now. 5, you can definitely hear it. That's no longer a sine wave. 6. And 7 is the maximum. And it's gotten very buzzy, hasn't it? And we bring it back down to 0 and it's a pure sine wave. So the feedback clearly adds harmonic content to our wave, and it moves from a sine wave through the various sharper waves, getting more and more buzzy sounding until we reach the maximum. Now we don't have the oscilloscope here with us today, but we'll actually show you what those waveforms look like on another video. Now we had promised to tell you about the envelope generators, so we're going to do that now. Okay, we're here with the attack rate for operator 4, and I made a mistake earlier. These only go from 0 to 31. So the attack rate, the decay rate, 0 to 31, whereas the level goes 0 to 15. I think I said up to 99. It's the output, the level output that goes to 99. But the attack rate only goes between 0 and 31 as you move your slider. Now in order to hear the attack rate effect, we're going to have to bring down the sustain level, because remember, this thing is just set key on, maximum volume, key off, no release. But perhaps we could demonstrate the release parameter first, since since that's easy to do without changing the envelope. Right now we have absolutely no, I'm going to press the button here for the release rate, which is 19 as you can see. All these are the envelope generator buttons. So we press the release rate and we come over here and we see right now the release rate is set to 15, which is the fastest instant release. Hear it there? You don't have any kind of release. Now when I drop it down now in numbers as I come down, eventually we will hear a definite release time. Like if you get down to 8, take your finger off, it's still not having much of an effect. So that means that those higher numbers don't seem to make much difference. You're not going to get more than a very subtle effect by changing them. But by the time we get down to 4, I've taken my hand off the keyboard. Notice it takes a while to fade out. Let me back off so you can see. I touch a key and you hear it fade out over a period of time. That's the effect of your release rate, gradual decay. Bring it down to, let's bring it down to a lower number. Bring it down to about 2. 1 is the longest. 1 is going to take a long time to decay. In fact, 0 is the longest. 0 is very long. Let's leave it at 2. Well, try 2 and see what happens. Let's press a key. See, it's taking ages to decay. Right? So your usable range on your release rate, what's your usable range? From 0 to 6. Beyond 6, between 6 and 15, you can't really hear much of a change. Let's set it back to 6. And I'll prove that to you quickly. There it is, release rate set to 6. You can just hear a slight thing like a little reverb. If I go to 7 or 8, 7 for example, and 15. You can tell the difference between 7 and 15. But what about 8 and 15? And 15? Not much difference. So about 8 becomes almost instantaneous. So you've lost all those numbers between 8 and 15 except for a very subtle change. Alright. Okay, in order to be able to show you the attack and decay parameters, we are going to have to bring down the sustain level, because as long as the sustain level is at maximum, we could show you the attack because the attack goes up to maximum. So let's go to the attack then. We go to the attack. Press the AR button, attack rate. Now as we said, it's 31, which means an instant attack. So we drop that to about 12. Drop that to about 7. Notice we're having a slow attack there. Drop that to about 3. Hold the key down and it gradually comes in. Gradually comes in and builds. Want to see that again? Alright, we can drop it to 2. There we go. Press the key. Sound gradually builds to a maximum. Put it back to 31. And you get instant sound. Okay, so let's tell you what the range of that one is. I mean, as I said, these numbers are not linear. You'll be having fun between 1 and 10. Beyond 10, the attack gets so short that you really can't tell much of a difference. For example, let's just show you, let's just prove that to you. I've got an attack of 10 here. And I've got an attack of 14. See, it's not much difference. So I would say maybe 10 is a bit conservative. You could probably hear the difference up to about 12. And that's okay with that. Now in order to show the decay, we're going to have to bring down the sustain level. And remember I told you to do that, you have to come to the D1L button here, D1 level. Decay 1 level is right now at 15. If I have that, I have the decay level to about 7. Now we're going to get some sort of sharp attack. Let's adjust it here so you'll be able to hear it. Okay, here you can hear the attack and the decay to a low level. Well folks, that's it for today. Thank you for watching us on the Stephen Mendes channel, and we'll see you soon again.